the solutions and knowledge. And I'm very happy to invite to the stage our first speaker, a person who is very open and very critical, and that's Mr. Leon Simon. So the stage is yours, Leon.
Let me welcome you.
So he looks like Indiana Jones, and he is going to be also as critical.
Absolutely correct.
Sorry, what was the joke?
I was joking. No, that you looks like Indiana Jones.
Okay.
You're perfect.
Thanks. Okay. Hello. I'm going to talk about accelerated warming and the climate risks for Europe. I hope the screen will work. As most of you will know, 10 years ago in Paris, there was an agreement made between all countries of the world to keep global warming below 2 degrees Celsius and try to keep it below 1.5 degrees Celsius. And that was done to reduce risks, to trying to reduce risks of climate change. So I think also what most should know is that climate change, so the climate change that we are now experiencing, it's not working. The climate has always changed, right? So that's, of course, an argument many climate deniers use, but there's truth to it. Let me see, oh, how does that work? So if you see this, the last time, before the last ice age, the last time it was as warm as it is today, global sea levels were about 7.5 meters higher than they are now. And during the last ice age, the sea levels were 132 meters lower than they are now. So I'm from the Netherlands, and at the time, of course, there were people, but I wasn't there yet. It's about 20,000 years ago. You could walk across the North Sea to England. And of course, you could also walk to Africa. And many places around the world where there's now ocean, of course, was covered by, you could access the land. But it's not just greenhouse gases that, oh, sorry, well, I should have gone here too, because I forgot where we are now, of course. Here, we are now here, and that's, the unit I use here is watts per square meter. That means that if you have the surface area of the Earth, which is 510 trillion square meters, for every square meter, there's about 4 watts per square meter. So that's like 1 light bulb of energy is additionally absorbed by the Earth system. It's forced into the Earth system. And if you translate that, of course, it's hard to imagine how much that is, but it's equal to 1 billion Hiroshima bombs of heat every year. That's, I think it's impossible for us to grasp how much that is. But it's not just greenhouse gas that cause warming. So here, let me see how does. Here you see the well-mixed greenhouse gas forcing. So how much warming the greenhouse gases, or the main greenhouse gases, are causing. And that's already more than 1.5 degrees Celsius. But here you see also sulfur dioxide. Sulfur emissions, they are a product of burning fossil fuels. There's also sulfur inside the fuels. And that sulfur comes out if you burn the fuel. And that reflects sunlight, but it also makes cloud brighter. It makes clouds brighter, so these clouds will reflect more sunlight. And that's why they cause a cooling effect, especially over the northern hemisphere, where 90% of us live and grow food. That's where these sulfur particles are being emitted. And of course, that's where now we reduce the sulfur, it's also warming faster. Let me go back to CO2. This is from 1972 report, Limits to Growth. the projection of CO2 in the atmosphere, and that's very accurate. Of course, you see the black line, and we have the red line here, so it keeps growing. And that's because these are CO2 emissions, global CO2 emissions and sulfur emissions. So in blue, 1 billion tons of CO2. So you see, of course, we are now almost just from fossil fuel burning at about 40 billion tons of CO2 per year. But the red line, that shows the sulfur emissions, and those haven't gone up together with the CO2 emissions. Why is that? Because there were clean air regulations to reduce these emissions. And this is the same graph, but for shipping. So shipping, that's of course how goods are shipped around the world with container shipping, with these large bunker fuel ships, but also for fishing. These also emit a lot of CO2, and those have been going. If you look at the past graph, you know, the global emissions, they have been unlinked from about the 1980s. So CO2 kept going up, but sulfur was decreasing. But for global shipping, they have been keep going up together, almost completely in the same line here, until very recently, about 15 years ago, because there were no regulations, air regulations over the oceans until that time. And then the International Maritime Organization introduced these regulations. And then in 2020, you see this enormous decrease here. It's hard to miss. And that's in 2020 when the 80% of the emissions were reduced because of the introduction of a global sulfur regulation. And why is that important? It's important because, of course, the oceans cover most of our Earth's surface, about 70%, but they take up 90% of the heat. 90% of the global warming is ocean warming. And then if you mask mainly the oceans and keep masking the warming of the oceans, of course, if you stop doing that, you can expect much more warming. So it was reduced again by 80%. And that's what we also are starting to see now. This is from NASA and NOAA, where they showed that there was a doubling in the rate of global warming. This was published in 2021. And in 2022, we first published our preprint of this paper, where we showed that we expected that the surface warming would also increase. Because the Earth's energy imbalance is how fast heat accumulates globally. So, like if you double that, it's like doubling the heat from a stove, for example, for your pan. If you're heating a pan and you double the heat, of course, you expect it to warm faster. It's quite simple. And that's what we expected. But there was quite some skepticism. They said, yeah, you cannot really say that, right? Because you see this green line, that was the linear change. So, and if you look at the red line, the long-term trend, it doesn't really go much outside this line. But as we said, we expect, especially during an El Nino year, where it's warmer globally, that this trend will change. And that's what we saw. This is an updated version of this graph. And then you see, of course, that it's very, very far from the green line. And the red line is also moving away from the green line. And that's acceleration, which it's really what you expect if you eat and put more heat into a system, whether it's your pan or the entire planet, it will heat faster. So there's a lot of consensus around that it has more than doubled. Earth's energy imbalance has more than doubled. Global warming has accelerated significantly. And by how much is then the question. And that's you might think that's easy, but it's quite difficult because there's a lot of variability. Sometimes the sun is a bit brighter. Sometimes there's a volcano that causes some cooling. Sometimes there's El Nino, so the cycle of the Pacific Ocean that causes more or less warming. Can I have some water? And then, but if you correct for that, if you try to understand what the temperature will be without this El Nino or with this El Nino, you can see that there's about a doubling in the rate of warming, about 0.43. And this is a warning call from the German Meteorological Gesellschaft and the Physical Gesellschaft. And then they warn that there's a global warming acceleration and that we could reach 3 degrees of global warming already by 2050. Thank you. So 3 degrees of global warming already by 2050. That's 25 years from now, and we're now at about 1.5 degrees. So that's quite a lot. It might be hard to imagine. Again, we're now already at about 1.5 degrees Celsius of global warming, and maybe it's a bit of a strange number, right? We have this strange politician in the Netherlands, and she's always like, yeah, if I put my house a few degrees warmer, or a few tenths of a degree warmer, who cares, right? They don't even feel that. But it's global warming, and that indeed doesn't tell you much, but it's also about what that represents. And again, it might seem a bit extreme, this warming, and of course it is very extreme, but it would just mean that the rate of global warming would not continue in a straight line, but keeps going up like this. And I don't think we cannot be certain that this will not happen. There's really a significant risk if we keep emitting greenhouse gases like at this rate, and we reduce the air pollution that was masking the warming. It will accelerate further. And this is very technical. I don't want to explain it all here, and I also want to show it because it's complex. And I just want to give you an indication of that it makes sense that we don't have all the answers, right? It's a complex system, and if you look here again, the 3 degrees by 2050. It's very high outside the model range, only a very small chance in the highest emission scenario that we could reach that. But that's based on models, and well, we don't live in a model. We don't live in a computer model, of course. We live in the real world. And then if you look at the real world data, at the satellite data from NASA, here, okay, you see the red arrows. Those are pointing at the satellite data from NASA, and that's the rate of global heat uptake portrayed in different ways, and it's outside all these ranges of the models. Right? You see again the models, and then there's the observations, and it's outside of the range. And that's I think why we really shouldn't assume that it's impossible to reach 3 degrees Celsius of global warming within 25 years, and it's of course just a date, but what it represents is really important. Again, because the cooling, of course, happened, the masking of the warming mainly happened over the northern hemisphere. About 1.5 degrees of cooling was caused by the air pollution, aerosols, as we call it. And even more regionally, over Europe, the summer warming is if you don't take into account this reduction in aerosols, you don't see the summer warming has increased by about 1 degree. and the overall warming in Europe by 0.5 degree. So you really have to take this into account. Because of course, if you don't take it into account, you don't expect the glaciers to melt, because it will not be cold, warm enough for the glaciers to melt. And you don't expect heat waves to kill tens of thousands of people, but which is happening, right? And in the Netherlands, we don't build the right dikes if we don't know how warm it will be and how much radiation there is. Because in the Netherlands, it's even worse. Sorry, let me go there in a second. But so this is the cloud. Again, these particles, they reflect sunlight directly, but they also make clouds brighter and longer lasting. And then if you see over the past, what is it, since 1980 to 2024, this is the change in cloud cover globally. Here is just 1 year, of course, there's some change. Sometimes there's more cloud, sometimes there's less cloud in certain parts of Europe. But the trend is very clear. And it's quite logical that then more sunlight is reaching the surface as well. And so that's increasing. So you can put these two lines together and you get this graph. About a 10% increase since 1980 of solar radiation from a decrease in cloud cover of about 10%. And that's really a lot. That's like the average, right? It's not one day there's like, okay, 10% less clouds. It doesn't mean much, but on the average over the whole year, over all of Europe, there's 10% less cloud cover. That's really extreme because it's a lot of heat entering the system. And for the Netherlands, it's the same. And you see these models the old models for 2020 from 2014. You see we're already way above what will happen in 2021, right? So these models are, completely useless to understand this, right? And this is the KNMI, and that's like the highest, one of the most recognized national meteorological organization in the world. But even there's updated scenarios. Even now, we are way above that. So much more sunlight is reaching the surface of the Netherlands, about 30 watts per square meter, and that's day and night. It can sound maybe a bit strange, day and night sunlight, but it's just the average over day and night at 365 days a year. That's 30 watts. It's like like the old light bulbs. I think most of you still remember them. For every square meter of the surface of the Netherlands. So that's really a lot of heat entering heating the Netherlands. And then I think we should talk about why that all is important. Because, again, a few degrees Celsius, why does that matter? Again, locally it's much more, but also for Greenland, for example, it's reaching a point where it will start to melt faster and faster. I think it's already about 30 million tons per hour on average. Also mind-boggling amount of ice is already melting. But if it would melt all the way, if all the ice that's on top of the Greenland island would melt, global sea levels would rise by 7 meters. And West Antarctica would also melt by, if a West Antarctic ice sheet, there's two big ice sheets on Antarctica, one is on the east, and that's a bit isolated, so it will take more time to melt. There will be more warming needed. It's at the bottom here, East Antarctic ice sheet. But that's about 40 meters of sea level rise. But the West Antarctic ice sheet is smaller, and it's mostly on the ocean bed. So then it can melt much faster. And that would have a 4-meter sea level rise response. And then the AMOC, I think that's also important to note. What is the AMOC? That's heat transported through the Atlantic Ocean northward. And we already can see the AMOC slowing down. Very uncertain, all this data. But yeah, that's what we have. So I think one thing to note, we really need better data. We really need to better understand what's happening, because all the risk involved, right? If the AMOC, if the North Atlantic receives much less heat from the tropics because the ocean current slows down, the climate of Europe can change completely. And that happened already in the past. You can see, for example, from ocean cores, lake cores, where they drill in the lake, in the volcanic lake in Germany. You can see the climate of the past 20,000 years. And then very accurately, because when you have these deposits, there's no oxygen in the lake, and then you can quite see what kind of plants they grew there, etc. Within about a year, a few years of accuracy. And you see that the Western Europe climate changed from within 5 years, less than 5 years, completely, about 8,000 years ago. So we know that these kind of complete changes can happen, and that would really completely impact agriculture of Europe. Winters could get like, especially the northwest, could get like minus 20 degrees. Of course, you know, you experience that sometimes, but we don't experience that. So that would be very bad for our infrastructure. So this is again the call from the German Meteorological Organization and the Physical Gesellschaft, what is that in English? Society. We therefore call on all political actors to become aware of the real danger posed by progressive man-made global warming and the urgency of action. And this is an opinion piece we put in a Dutch newspaper, where we also call for taking climate change, I think, more seriously, or at least as serious, right, as war. There's a lot of fear in Europe about war, and of course there is a war. There's a war going on on the east of the side of our continent. So it makes sense to be afraid of that, but we really shouldn't forget about climate change. Right? There's a lot of money is now being allocated to invest in bombs and everything, but we really need to invest in adapting to the changes that will come very fast. It's almost impossible to explain or grasp how fast everything is changing. And then just want to cover this a bit as well. Again, when we talk about risks, these are the principles of risk assessment by Simon Sharp. He explained this, and of course, we think a lot about terrorism. Of course, in the United States, this fear of terrorism is even worse, and it's understandable. But the risk of it happening, right, it's very small. While climate change is certain. So we have to identify the biggest risks, and I consider the full range of probabilities. Again, if 3 degrees by 2050 is low probability, but the impact is really extreme, right? Tropical reefs will die, or they already do more or less, right? And then we will lose our country. And I don't know exactly, like in this region, what the biggest impacts will be, but you can imagine, like if it's warming, the glaciers will melt, your water reserves will be changing, right? When we have water, how do you protect your water? How do you have, for example, in France, what happens if you have more drought, more extreme drought? What happens to the hydropower production? and the efficiency of power plants, whether they are nuclear or coal or gas. If you have more extreme storms, can your infrastructure? I think that's to summarize it. Is your infrastructure future-proof, right? And what does that future look like? I think that's the main question. Now, if you think we have to make our infrastructure future-proof, if I build a power plant or windmill or whatever, what's the expected lifetime, and what will the future look like over its lifetime? And then if you have these storms that break your windmills or your solar panels because you weren't expecting this, yeah, that's a big risk. So we really should identify this and act on it. And this is what I always point at. Climate, it has always concerned me that our use of the word conservative has opposite meaning in insurance to its meaning in science. So many scientists are conservative, and they don't want to be wrong, right? They don't want to exaggerate. But that's right. I'm not exaggerating. I'm just showing you the data, saying this is maybe the chance is not very high, but it looks like it could happen, right? There's no exaggeration, just showing the data. Okay, thank you. And now I have some advice based on all these findings. So climate change is a risk to the survival of Europe as we know it, and should be approached as such. We need much faster greenhouse gas emissions reduction, much faster reduction in greenhouse gas emissions. And reducing methane, that would really help to reduce the rate of warming, because it has a much stronger warming effect and a shorter lifetime in the atmosphere, so it will reduce faster. And we need to improve these climate models to better assess regional risk as well, right? Globally, they are, right, if you just take the average of the whole Earth and then over time, and you just look at like the 30-year average, you're not, it's logical that you don't really see the changes, the rapid changes, right? Or the changes in the rate of warming, because you just average everything out and then nothing really changes. But if you look at the regional changes, it's much more clear. And we really need to secure these satellite data from NASA. And that's, of course, with the current administration, it's already difficult, but we have even, like, you cannot access the data. They will not update it now because the government is closed, or what. I don't know how the system works, how you can just close up your government because you cannot agree on some budgeting, but let alone for such a large country. But yeah, that's what happened. So I hope they will soon get the government back online and then get the data back, and we really need to cooperate with them to get more or these smaller satellites in orbit, because it's really crucial data. And we have to adapt in line with the change in the real world, and then also to research into possibilities and associated risks to prevent climate extremes, including controlled regional cooling. And that's doing research, because if a country or an organization or a body experience that the impact is too bad, and they want to start cooling, but they don't have the research done, the risk could be higher than the reward, let's say. So then it could have disastrous consequences. And then I want to end with this drawing made by my daughter. It says the sea enters through the mail slot. And this, at school, she's 9 years old. And in school, they were reading this book about the 1953 flood of the Netherlands. And we have of course, in school, we need to let the children learn what changed, or of course about history, but also like in our country, which is for 30% below sea level, they learn what that means. They learn why we have these dikes everywhere, right? And what happens, why there's often these lakes there, because that's when a dike burst. And then there were these 30 meters deep swirl holes, and so they learn about that, but then they use these things also to learn about the future and to try to avoid this. And I think that's, I don't know how that's like in your countries, but I hope you also teach your children at a young age about these changes. Thank you.
Leon Simons, Indiana Jones from Netherlands. Thank you so much. We appreciate your speech.
Thank you.
Thank you. Terrible. Let me speak in Slovak because we had the ladies.
Okay.
They will translate it for the people from other countries.
So if a man like Leon from Netherlands shows at the end of his presentation, when he shows the impact, and when he shows the sunrise and the cloud cover, when a man from the country of 18 million people, with 1/3 of the country being under sea level, if this man says that other country 9-year-old children already understand the past, they have learned from the past years.
Just because of you. Jdeme od začiatku. So
that he understand, because I'm talking about him and he doesn't understand. So once more for Leon, if a man from Netherlands, from the Kingdom of Netherlands, with 18 million of inhabitants, when 1/3 of country is under sea level, if he talks about the change coming very fast, showing cloud cover going down, sunrise going up, you don't expect it, suddenly you have a tornado coming, or the wind, strong wind, and our mills just disappear, our tulips and our export pride just disappears. If this man who looks like Indiana Jones, it was a joke, if such a man says at the picture of his 9-year-old daughter that we already educate children who know what happened in 1953, and they are instructed and they understand what can come, and that he hopes that also us in Slovakia, we educate our children. If when he says something like that at the end of his dreading or dreadful presentation, I'm asking why in our government we have 50 or 55-year-old people who are not able to draw such a picture. I'm sorry for my sarcasm. I needed to say it.